Hi everyone, welcome back. Today we're going to be talking about properties of exponents. Our objective today is that you will be able to use the product of a power rule and the quotient of a power rule to simplify exponent expressions. Now, the way we're going to tackle today's video is actually going to be broken down into two parts for you. One part we're going to do half of the problems, and then there'll be an optional second part of the video that you can come back and watch if you need a little bit more practice or you want to see a few more problems. The first property we are going to talk about today is the product of a power rule. And I like to think about these properties with just really basic exponent expressions. So the first one we have here is x to the third times x to the seventh. And really what we're trying to figure out here is what happens if we multiply two things that have the same base together. And we can break this down really simply. We know that x to the third is really x times x times x. And we know that x to the seventh is really x times x times x times x times x times x times x. Now, these two ideas are being multiplied together, along with each of these x's over here. They're all being multiplied together. So when we look at this, what we really have here is just groups of x's that are being multiplied together by one another. Now, whenever we see this happen in math, we know that we can use exponents to help us represent this situation. So if I wanted to look at this and rewrite this in terms of exponents, since I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's, we could rewrite this as x to the 10th power. So what we find out is that x to the third times x to the seventh is equal to x to the 10th. Now, I want you to think about that from a little bit different lens here, because we don't always want to be breaking these down and writing them out. How can I get from an exponent of 3 and an exponent of 7 to an exponent of 10? And hopefully you're saying, well, you just add those exponents together. 3 plus 7 would give us 10, and we'd be done. Now, one thing I do want you to notice here is that notice how our base on this problem and this one were both the same, right? X and X. And notice how our ending base changed or didn't change at all. It actually stayed the exact same. It's still X. In all of these problems today, our base isn't going to change. What's going to change is going to be our exponents. We might regroup and put stuff together, but our base is not going to change. So whenever you have two things that have the same base and they are being multiplied together, what we need to do is we need to add the exponents together. So just like we said before, our base is not going to change. It's still going to be a. And then we just need to add our exponents. So our finishing exponent would be n plus m. And this would be what we call the product of a power rule. In a minute, we'll go through and we'll look at some more problems and we'll get to practice that rule in a little bit more depth. Let's take a look at another one here. This one's going to be called the quotient of a power rule. So up here, I've already written one down that we're just going to try to figure out what this rule is on our own. So we have x to the seventh over x to the third. And again, what we're going to do is we're just going to start by writing this out. X to the seventh is just x times x times x times x times x times x times x. X to the third is just x times x times x. Now, in math, whenever we are dividing, and we have same quantities in the numerator and in the denominator, these two quantities actually cancel each other out. So we'll cancel, cancel, cancel. Now, looking at this, what we notice is that we're left with 4 x's up top. So another way we can rewrite that is x to the 4th power. Now, since there's nothing on the bottom, we're going to hold the bottom of that fraction for a second with just a 1. So we have x to the 4th over 1. And of course, that just becomes x to the 4th. Now, that's great. We did a wonderful job. Now let's just think, how could I get from 7 and 3 to 4? And hopefully that's jumping out at you too and saying, well, if you just take 7 and you subtract 3, you would get to 4. So 7 minus 3 would get us to that same power. Whenever we are actually dividing here, we subtract the top exponent. It's really the top exponent minus the bottom exponent. 7 minus 3. And that will give us our final answer here. So we'll rewrite that and generalize it in a second. But let's see what happens if the bigger exponent is actually on the bottom. So if we look at one more sample problem like this, x to the third would be x, x, x. And on the bottom, I know that I'm going to have 7 x's. Now, just like before, we are allowed to just cancel, cancel, cancel. Now in this one, the top of the fraction, the numerator, doesn't have anything left, so we're just going to hold the top of that fraction with a 1. That's kind of our holding value in a fraction. And on the bottom, we still have 4 x's, so we know that we can say that as x to the 4th. And this would be our final answer. Now subtraction with that looks a little bit funnier because we would actually end up with a negative exponent, right? X to the 3 minus 7 would give us x to the negative 4. And that actually becomes a much bigger problem from how we actually turn this into this. But we'll get there in just a couple of days. So for right now, I want you to hold on to this idea of with this type of problem, we can actually just string it out and cancel out those values that are on the top and the bottom. Now, again, like we said, subtraction is the main idea that's happening here. So let's generalize that over here. We have two things with the same base, and same base that are being divided, and they both have exponents. And what we do is we take the top exponent and we subtract the bottom exponent to get to our final answer. So we would have a to the m minus n. Now, sometimes I actually like to explain this too, so I'm going to say top minus bottom. Right, just so that we know we're talking about the exponents, right? These are exponents. And this is what we call our quotient of a power rule. We have 2 more rules to get through, and then we're going to sit there and start going through some problems. Here's our next one. We're doing the power of a power rule. So our question is, what happens if we have a power that is being raised to an exponent? Now, the way we want to think about this type of problem is that if we think about this through the lens of that is the base and this is the exponent, then what x to the second raised to the 4th power really is it's just x to the second times x to the second times x to the second times x to the second. Because, remember, our exponent tells us how many times to multiply our base by each other, or by itself. So we're going to multiply our base by itself 4 times. Now, we can simplify this even more. X to the second is just an x times an x times an x, an x times an x, and an x times an x. So I really have, it looks like 8 x's that are being multiplied together, so we know that that's going to give us x to the 8th. So let's think about this for a second. If I had x to the second and I raised it to the 4th power, how did I get to x to the 8th? Well, we multiplied our exponents together. And that actually becomes our more general rule over here. Whenever I have a power that's raised to an exponent, we multiply the exponents together. And that will give us our final answer. This is going to be true in almost every problem whenever we're dealing with these exponent problems where we see parentheses. Whenever you see those sets of parentheses there, those parentheses are going to be your clue to tell you to multiply exponents. In the past, I've had students that like to use the mnemonic PMME. Parentheses mean multiply exponents. Anytime you see parentheses, you know that you need to multiply exponents together. All of the exponents on the inside by that outside exponent. Here's our last problem over here. Now, again, I would have students that are jumping up, hopefully saying, Block, that's a PMME problem. Parentheses mean multiply exponents because they're seeing these parentheses here. They're right, but before we get to that part, let's sit there and break this down. If this is the base and this is the exponent, this would tell us to take x to the 3rd, y to the 2nd, times x to the 3rd, y to the 2nd, times x to the 3rd, y to the 2nd. Right? We take the base and multiply it by itself 3 times. Now, if we just regroup this for a second, it looks like we have 3 x's, 3 x's, and 3 x's. If we put all those x's on the same stack, we would end up with 9 x's total. Same thing with the y's here. If I have 2 y's, 2 y's, and 2 y's, y squared y squared, y squared. If I put all those y's on the same pile, I'm going to get y to the 6th power, making this my final answer. X to the 9th, y to the 6th. Now, again, we always want to think about, well, how do I get from my starting expression to my final one? Are there any shortcuts I notice? And hopefully you're saying, well, if you just multiply the 3 times the 3, you get the exponent on the x, which is 9. And if you take the 3 times the 2, you'd get the same exponent that is on the y. And that's exactly what we do. We multiply, right? PMME. Whenever you see parentheses, that means multiply all of the exponents on the inside. So right here, notice how we don't see any exponents on the inside. We can put a 1 and a 1 there to hold those spots. We know that 1 times anything is just whatever you multiplied it by. So when I multiply m times 1, I'm going to get m. And m times 1 again is also going to give us m. So our final expression here, when I raise a power to a power, would be a to the m, b to the m. Now that we've went through and we've figured out our 4 rules here, we're going to use each of these 4 rules as we work through the next sets of problems. These rules are very important, so you maybe want to star those in your notes or highlight them just so that you know where they are and you know we're going to be using them a lot. So again, this is where we're going to do half. So I'm going to do this half of the problem over on the left side of your note sheet, and then part 2 of your video will come back and I'll just do the last remaining problems there. So let's try to put it all together. So when we see a problem, we see that we're multiplying right here, right? That's what that symbol means. So we can multiply our outside numbers, our coefficients, just like we normally would. 2 times 2 is going to give us 4. Now is the part that's new to us. We have m to the 2nd times m to the 3rd. Now, these 2 things, again, please notice they have the same base. Whenever 2 things have the same base and they're being multiplied, you can go right back up to your list and you can see 2 things that have the same base that are being multiplied. All we did is we added those exponents together. I'm hoping that you'll use these rules until you get really good with them. So if I have m to the 2nd and m to the 3rd, I just need to add those exponents together. So my final answer is going to be 4m to the 5th. Nice job. Let's do the next one. Again, we're just working down. So we're going to, if you wanted to see this problem, we're going to come back and do this problem in part 2. Here's our next problem. Again, hopefully you're seeing these parentheses and you're thinking to yourself, PMME, that's our shortcut. Now, one thing you might notice is that the 4, you don't see an exponent on it. So we got to put a little 1 up there to hold that spot. Everything has to have an exponent on it. So if we don't see an exponent on something, we put a 1 up there to hold it in a problem like this. Parentheses mean multiply exponents. So we're going to come over here and we're going to multiply the outside exponent to each of those inside. So we're going to get 4. And now we got to think to ourselves, what is 1 times 2? Because that will be our finishing exponent. 1 times 2 is, of course, 2. And then we get to the a term. So a, right, again, our bases don't change, only our exponents change. We would have a to the 3 times 2, which gives us 6. Now, this is really close to a right answer. We can do just a little bit more. We do know what 4 to the 2nd power is, right? That is 16. So we can turn this into 16a to the 6th. Nice job. Let's keep moving along here. Oh, here's another one, right? We're seeing that they're being divided. So let's go review what our rule is up top. How do we divide exponents? Hopefully you zero in on the quotient of a power rule here. And it looks like whenever I divide 2 things that have the same base, we need to take the top exponent and subtract the bottom exponent. So let's see what that looks like here. Now, we can either take the top minus the bottom, or what we can do is maybe you like that string it out idea that we did earlier. So let's try that. So if I have r squared, that is just r times r. On the bottom, I'm still going to have the 2 down there. And then I have r to the 3rd power. And r to the 3rd is just r times r times r. Remember, anytime you have the same thing on the top and the bottom, we can just cancel those out. If you notice, on the top of this fraction, there's no longer anything there. So we need to hold the top of the fraction with a 1. That's always our holding value in a fraction. On the bottom, we're just left with a 2 and an r. That's all we had left. So we're just going to rewrite 2r, and we're done. Nice job. Moving on to the problem below it. Again, we see we have another dividing one. So let's string this out. M to the fourth is m times m times m times m. Bad m. Let's do another one. And on the bottom, I'm going to have the 2, and then 4 m's as well. We can cancel our m, cancel our m, cancel our m, cancel our m. It looks like everything up top was canceled, so we're going to hold the top with a 1. And then we get to the bottom, and we're only left with that 2, making 1/2 our final answer. Great job. If you looked at this problem initially, and you said, well, if this one just has 4 m's up top and 4 m's on the bottom, and you knew that those 4 m's were going to cancel each other out, you can almost skip this string it out step right there, but you should still be able to get from there to here, right? You should still be able to get to that same answer. Looks like we have just 2 more problems to go, and then in part 2 of the video, which is our optional part, you can go back and rewatch those additional problems if you'd like to see more. Right here, again, we see that we have parentheses, and parentheses mean multiply exponents. That's our PMME. Parentheses mean multiply exponents. Everything inside has an exponent, so I'm just going to take 3 times 3, and I would get n to the 9th. Now remember how we started this, ladies and gentlemen. We started this out today by taking this expression and saying if this was the base and this was the exponent, then what this would mean would take n to the 3 times n to the 3 times n to the 3. If you like the idea of stringing it out and that helps you, that's a good strategy, right? We want to take advantage of all that intuition that we do have in our brain. And if you can get to n to the 9th the same way, just like we already saw, you're doing just fine. Let's do one last problem together for this part of the video, and then again, we'll come back in part 2 and I'll do those additional problems. Last problem we see, again, we do see that we have parentheses, so we will be multiplying exponents. Whenever you want to do this PMME process, you need to put in any missing exponents that you see. That 2 did not have an exponent, so we got to put one in for it. Then we're going to multiply and multiply. So I'm going to get 1 times 4, which is just 4, and 2 times 4, which is 8. Now we can just go a little bit further with this. 2 to the 4th just means 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we know 2 to the 4th is 16. And then the b to the 8th is going to sit right in front of that. Again, ladies and gentlemen, if you want to see more practice, we do have some other problems over there that look like they get harder. We're going to do those in part 2 of the video. Thanks for watching.